Nice to meet all of you online. Good morning to all of you.
Good
Actually, my
morning, sir.
session was on Friday, but I
Yes.
think this is some alternate arrangement, and because of that, actually, I am somewhat earlier, right?
Yes, sir. And thank you
Okay.
so much, sir, for that adjustment.
Yeah. Okay. All right. It's
Yeah.
fine. So today we will discuss about Internet of Things, and it is a basic of Internet of Things. And I would like, if time permits, I would like to show some demonstration also with Internet of Things, right? So I hope that the slide is visible on the screen to all the members, right? Slides are visible.
Yes, sir.
Okay, good. So this will be our overall session or outlines. Today we'll be looking at a brief overview of IoT architecture. Then what are the elements are there in IoT? We'll see some details of sensors. We will also see some what are the protocols being used for the IoT. We will see Arduino programming for Node MCU. You must have studied, as it was told today morning, that Arduino is already covered by Kiran Trivedi sir. So all of you are now very much familiar with Arduino IDE. The same IDE is useful to program the Node MCU. The device control using mobile application, I will try to demonstrate one application here. But today's session will be about 1 hour or some few 10 minutes after that. So I may not be able to cover remaining two topic today, device control using web application and uploading sensor data on cloud. That may not be possible today. But I think again we will meet on Saturday, where this part I can cover again. So if you look at the Internet of Things, I will try to okay, move it somewhere else so that visible. Okay. So all of you now must be very much familiar with Internet of Things, because it is a buzzword nowadays. It is IoT is a scenario where network connectivity and computing capabilities extend to objects. In the internet, actually, we human beings are connected with a network. We communicate with each others. We do the surfing and we do check the emails and all that. But IoT is a scenario in which, apart from human being, all the objects will be also connected with the internet. And many of the objects nowadays are connected already with the internet, and we are using it in many of our daily applications. So basically, all sensors, actuators, and everyday items, they will also participate in exchange of information. So that is what is actually IoT, Internet of Things. So this diagram shows that everything is connected along with this smart key and bicycle, and many objects are shown here in the figure, where everything is connected with the internet, so that you will be able to get the sensor data anywhere from the world. You will be able to control the devices sitting anywhere in the world. So ultimately, in the Internet of Things, we have a smart sensors. And smart sensors are basically, we are trying to communicate the data from smart sensor to the cloud system. So if you look at the smart sensors, there are different types of smart sensors. A different category of smart sensors are available. Out of them, there are position or presence or proximity sensors are there. I would like to show you one of the sensor available with me, which is known as if this is visible to all of you, is a PIR sensor.
Yes, sir, it is visible.
PIR sensor. So PIR sensor also we can connect with Node MCU, and this sensor data we can communicate to the cloud, or using these sensors, we may have a certain applications, like if someone is near to these sensors, then automatically the solenoid will on, automatically something will happen. If this sensor, if somebody is near to this sensor, then there may be alarm, or that type of application can be, we can build. Then similarly, there are different types of sensors, like ultrasonic distance sensor is this, if it is visible to all of you. is ultrasonic sensor. So this also we can connect and measure the distance. So ultrasonic distance meter we can prepare with help of this type of a sensor. Then we have a different motion velocity sensors are also apart from displacement. If you want to measure the motion, if the velocity, then there are the sensors are available. And the wide variety of sensors are available and easily available. Now you can give the order online and it will be available to you. There are temperature sensors like LM35 and US 1800 and many others, digital as well as analog temperature sensors are available. Then humidity and moisture sensors are available. Like one I will show you here with me. This is actually a DHT sensor, DHT22 sensor, which can measure the humidity and temperature. We can connect this sensor with node MCU and can measure the humidity and temperature. Then there are many sensors for acoustic and sound and vibration measurement. Then chemical gas sensors are there. Particularly useful in chemical industries as well as wherever there is a gas leakage is there. So for gas leakage alarm, we can use this type of sensors. Then there are flow measurement sensors are available, which can measure the flow, liquid flow. And particularly nowadays, people are using these sensors for a certain applications like they want to detect the water leakage and inform concerned local municipal corporation authority that at this place there are actually a water leakage is there. And because of that, there is some disparity in the flow and they can alert the system to find out the leakage. Then there are force, load, and torque strain type of sensors where these sensors are mostly they are using strain gauges to measure the force or a strain or a pressure or kind of a parameters. These sensors are normally, if you have seen the weighing scales where this type of sensors are mostly useful. So weighing scale will not only display the weight locally, but you can transmit the weight anywhere in the globe with help of a IoT. Then there are various leakage and level sensors are there where you can monitor the levels in a tank, liquid levels in a tank with help of this type of a sensor. There are various electric and magnetic sensors available for to measure the acceleration or a tilt. Then if you want to do the surveillance, then machine vision optical sensors are also available. Video cameras are there, which you can connect with Raspberry Pi kind of a hardware. And then you can communicate your video or an image anywhere in the world for security purpose or for a monitoring purpose. So various sensors are available, which are very, very useful for Internet of Things applications. Then there are many cloud computing services are available. Very famous services are like Microsoft Cloud Services, very, very famous, IBM Cloud, Amazon Elastic Compute Cloud, Citrix, Joyent, Bluelock, Version, Salesforce, Rackspace, Google Cloud, ThinkSpeak, DrewSoft, NetMagic, and UBDots. I have listed very few here, 14 only, but there are many more apart from these. There are many cloud services are available, and many cloud services are free for students. For initially, they allow us to use the freely, but for commercial, we have to pay fees to the cloud services. These are the few cloud infrastructure services are available for used with IoT. ThinkSpeak and Jively are very, very useful to store and use sensor measurements. If you are using MATLAB, the MATLAB is a very good tie-up with ThinkSpeak. So you can, those MATLAB users, ThinkSpeak account is given free of cost. The tweeter allows object to talk humans or receive commands. So you can just tweet and control the devices with help of a tweeter. Then Yeller is also available. Zapier and IFTTT allows mess up of web services. So IFTTT, you can the voice command. You can say the device on, then the device will become on. You can say device off, the device will become off, and so this type of services are available. These are known as IoT infrastructure services. About the sensor to cloud. So basically we have a various sensors which we have discussed. That is the GPS sensor, electrochemical sensor, photoelectric sensor, RFID, gyroscope, electromechanical, etc. Whatever the sensor category we have seen, that is known as a sensor layer. Then our job is to transfer the data from sensor to cloud. So for that you require some kind of a network. So now there are different possibilities. Sometimes you require data within campus. You don't want to send outside the campus. Then only LAN is sufficient. Then a LAN you can use a Wi-Fi or Ethernet connection, and your data will be available locally within the campus. If you want your data within a room, let's say, then you can use a personal area network kind of a thing. There's a PAN where you can use the Bluetooth or NFC, near field communication. So within a room, you will be able to send the sensor data to the devices with help of a PAN network. So there is a possibility how much distance you want. Now, sometimes you require to send the data anywhere in the world. So in between, just give me the feedback if I'm not audible, because sometimes otherwise what I will do, I will continuously speak and will not get any feedback from you. So just give me a signal whenever you do not get my voice or you do not get the my
So
screen.
right now voice is clear.
Voice is clear and screen is
Yeah.
also available, right?
Yes, sir. Yes.
Because sometimes what happens due to the network delay, there is a
Yes,
lagging
yes.
in the screen and voice, and sometimes that happens actually. Okay, good. So if you want to send the sensor data not only within a campus or not only within a room, and if you want to send the sensor data anywhere in the world, then there are different types of networks we use, which is what we call as a heterogeneous network, where there may be a GSM or UPS or 4G, 3G, 3G, 4G, 5G kind of a mobile network. So it is known as LTE and upcoming. Sometimes satellite also comes in a picture. Fiber optic link is also comes in a picture. So entire wide area network we are using to get the sensor data to the remote place. And there will be a cloud system. So normally we will be sending the data from sensor to the cloud with help of this heterogeneous network. Then after there is application layer. So in application layer, there are many applications of IoT, like in agriculture field, consumer field, healthcare, transport, infrastructure. There are industrial applications, military applications. So all these applications where there will be a front end tools will be also there to display the data correctly with graphics and all that. So application layer have a many applications, and it's a job of responsibility of programmer to prepare a different application uh, to provide a graphical user interface to the users, so that they will be able to use that graphics to control the devices as well as to get the device data directly on the screen. These are some of the elements of IoT. Where we were discussing about the devices and then any connectivity. So devices will have all the sensors will be there. Then edge devices will be there. So sensors will be connected with the hardware like Node MCU, Raspberry Pi. And then it will be able to connect with the net with help of any connectivity, heterogeneous network, like we talk about the Bluetooth and Wi-Fi, then local area network, or heterogeneous network like 3G, 4G, 5G, or a fiber optic link. And then we use different protocols. And then there is a rule engine is built. Some storage is also required here because sensor data is coming, so you have to store it somewhere locally in the cloud. And the application, what it will do, it will get the data, process it, and pull back the result to the cloud. So application is where we will be providing the user interface where UI and UX will come in a picture. So our basic job will be a sensing, and then after sensing, the communication to communicate the sensor data through heterogeneous network, and then cloud for storage and analysis. So the job of cloud is not only storage, but sometimes it will also do the analysis. And then application for end user. So here there is application where the end user will use the data. So the data will not be in a raw format, but it will be in a usable format. Again, here there are different options are there. Sometimes we do not do computation at cloud. Sometimes we do local computation on edge devices. Like if you have a Raspberry Pi kind of a devices, we will not send all data to the cloud, but instead of that, we will do some local computation, and whatever the result after local computation is there, that we only send to the cloud. So in that, you require less communication between the cloud, and your cloud space will also save. And cloud will not be, becomes busy for unnecessary computation. So most of the computations which can be done also at the edge devices. Or sometimes people want that I don't want to do anything at the edge device. Just edge device is useful to transmit the data directly to cloud, and everything else will be done at the cloud. So there are different possibilities are there. Different architectures are there for that purpose. Sorry, actually I forgot. Okay. Okay. The IoT devices. The role of IoT devices is to collect some data from the sensors, then process it and send actuating signals to the actuators. Actuators means relay, solenoid, even we can say that DC motor, AC motor, servo motors. These are the useful actuators in real life applications. If the controlling devices are not connected with internet, then system is known as embedded system. So we were using the local sensors, which is communicating to the microcontroller, and then microcontroller will control the actuators. But in that case, everything will be local, and then we call it as embedded systems. But when we say that these entire embedded systems are connected with the internet, so when controlling of the devices are there with help of the internet, then system we call it as IoT based system. So embedded systems, most of the embedded systems are being converted into the IoT systems because people want everything from the remote place. And that's why IoT devices are increasing day by day. So this is a very basic Arduino Nano 33BLE Sense IoT device. The Kiran sir has already described you the Arduino board, but simple Arduino board like Arduino Nano and Arduino Uno doesn't have a capability of connectivity. So there is a 33BLE Arduino Nano board is there, very simple, which is very much similar to the Arduino, but only the Wi-Fi capability is extended into this. And in a normal Arduino Nano board, there is a Atmel AVR microcontroller, Atmega 328. But here it is having a ARM Cortex M4 microcontroller. ARM is the advanced microcontroller, 32-bit microcontroller. So it is available with the board. It has a 8 ADC input. So total 8 analog sensors you can connect with this board. And all the ADCs are of 12-bit. Now I want to interact with the participants that what do you understand by number of bits in ADC? Suppose I say that 3-bit ADC, what is the actually meaning of that? If anybody can tell me.
Yes, sir.
Say whenever I'm saying that the ADC is of a 12-bit, what is the meaning of 12 bit? Suppose if I say instead of 12, 3-bit ADC, Then what is the difference between 3-bit ADC, 8-bit ADC, and 12-bit ADC? If any participant can tell me.
Sir, am I audible?
So
Yes, you are audible.
simultaneously,
Please.
Sir, in 3-bit ADC and 12-bit ADC difference is of the resolution. Means
Very good. Very good.
analog signal has that many steps to get converted. So we will get
Perfect.
more details in 12-bit ADC rather than in 3-bit or 8-bit ADC.
Yes, yes. Very good. Very perfect. So if you have a 3-bit ADC, you will be able to measure only 8 analog levels. So if you have 8-volt signal, then the measurement will be in the step of 1 volt, 0 watt, 1 volt, 2 volt, 3 volt, like that. You will not be able to distinguish between 0 volt and 1 volt, 1 volt and 2 volt, because only you have 8 levels. But if you have 8-bit ADC, then 2 is to 8, so 256 levels will be there. So in this board, actually 12-bit ADC, 12-bit ADC means 2 is to 12. So 4096 levels are there. Right? So if you are let's say for a simplicity 4.096 volt, then 4.096 will be divided by 4096. Right? So the resolution is much better. So you'll be getting, in that case, you will be getting 1 millivolt resolution. So because of very good resolution, you will be able to measure the signals accurately because of this 12-bit ADC, and it is the 8 input. So you will be able to connect 8 sensors together simultaneously with the board. It has a 14 digital pins. It allows UART, Universal Asynchronous Receive Transmit, SPI, Serial Peripheral Interface, I2C, Inter-Integrated Circuit. All these are the serial communication standards. So all these interfaces are available with the board. So you can connect the devices easily with any of these 3 protocols. So suppose if you have a LCD which is having a SPI protocol inbuilt, then you will be able to connect the LCD with the board. LCDs are also coming with I2C interface. In that case, only you require 2 wire to connect the LCD with the board. Then Bluetooth module is also available internally within the board. So you can connect the device, your mobile phone, you can connect with this board, and you will get the data on your mobile phone directly. You don't require separate display also. You can use your mobile display to display the sensor data. Then there are many sensors available inside the board, like temperature, humidity, barometric pressure, gesture sensor, light, proximity, microphone. 9x6 IMU sensors are inbuilt inside the board. So if you require all these parameters, you don't require any other external sensors. All these sensors are already available in the board. If you require anything else, then only you need to connect it with this. But these are the inbuilt sensors already available in the. Then it is a 1 megabyte of CPU flash memory, 256 kilobyte of static RAM, and digital current per IO pin is given 15 milliampere. So this 14 digital IO pins are available. You will be able to draw a current of 15 milliamperes from the pin. That means you will be able to connect the LED directly with help of some current limiting resistor. You don't require any driver to glow the LEDs here. But if you want to connect the DC motor with this, naturally DC motor you will not be able to run with a 15 milliampere. So in that case, you require a IC driver like LM293D, L293D kind of a driver you require in between. Or sometimes you require a H-bridge transistor to amplify the current capacity. Then there is inbuilt Wi-Fi is also available with this board. So it's a very, very useful board. If some of you are conducting a lectures, or if you are conducting a lab of this subject, IoT, then you should procure these lab boards for your laboratory. Then these are the few more devices which are useful for the IoT applications. This is again Arduino Nano board with a Wi-Fi extension. Here you can see the Wi-Fi extension available here. This is Nano board, but this doesn't have any Wi-Fi capacity. Wi-Fi extension is not given to this board. This board again, you can see Wi-Fi chip is available here. As you can see here, Wi-Fi chip is available here. And in this board, Wi-Fi chip is available here. Here there is no Wi-Fi chip. In this 8 mega board also there is no Wi-Fi chip. And Arduino Uno board is also there, but here again there is no Wi-Fi chip. So for application, these boards are okay. These 3 boards are okay. But for Wi-Fi application, IoT applications, either you have to go for this board, or one more board is there. Node MCU is also there, and this is actually your the board which I was talking about. Then people are also using this Raspberry Pi, where in Raspberry Pi 4, Bluetooth and Wi-Fi both are available. Apart from that, Ethernet connection is also given. So you can connect your Ethernet cable with this board, and you will be able to communicate whatever the interfacing you are done with this IO pin. Like these are the all general purpose input output pin, where you will be able to connect the digital sensors as well as actuators. But unfortunately, in Raspberry Pi, ADC is not inbuilt. So if you want to connect the analog sensors, you require ADC outside the board. And then from the ADC, you will be able to connect the signal with the Raspberry Pi board. But in Arduino Nano Wi-Fi board, the inbuilt ADCs are available. In Raspberry Pi, inbuilt ADC is not available, but the advantage is that you will be able to connect the camera, either a Pi camera here, or you can connect the USB camera on the USB port. So you'll be able to get the video data also along with the other sensor data. So that is of Raspberry Pi. So if you require some kind of image processing or a video processing, and you want to send the video to remote place, then Raspberry Pi useful board. Okay, meanwhile, if any doubt, you can ask. I will clarify your doubt, and then we can go ahead. If anyone of you have any doubt up to discussion up till now.
Hello. Good morning, sir.
Hello.
Okay. Okay.
Hello.
Please.
Sir, good morning. Just
Good morning.
yesterday, sir told that the Arduino Nano 33BLE Sense device, it is useful
Hmm.
for the machine learning application. And also today you tell that the Arduino Nano 33BLE Sense / IoT module. So both are the
Yes.
equal module. Both are the
Yes,
same
both
module.
are equal to module. The Kiran sir will demonstrate the same board for the machine learning purpose also. I think there is a session is there on Friday, I think, right?
Means same
Yes.
same module can be used for the IoT applications
Yes,
also.
but the same module, you can use it for machine learning as well as for the IoT. So that is the beauty of that module actually.
Okay. Okay, sir.
So you will get the data, the sensor data, and then you will be able to apply the machine learning algorithms. And then after machine learning algorithms, you can send the result to the cloud.
Okay, sir.
It's very
And
good board, I think.
Okay. Sir, how much is the cost of this board?
Arduino Nano cost is around, okay, I have to search the new price, because nowadays prices day by day it is increasing. Raspberry Pi initially it was costing 4,000 rupees, but
No,
at
sir, no,
present
Arduino
the
Nano
cost is
33
about
BLE
12,000
sense
rupees.
Sir, this module, Arduino Nano 33 BLE sense module.
Just I will search, and just I am telling you, I am just searching for it.
Okay, sir. Okay.
Because I have to tell you the latest price, right? Day by day
Yes, sir.
price is increasing actually. Because of, there is a lot of shortage of conductor wafers nowadays. No, at present it is showing the price of 7,000 rupees.
7,000.
Yes, initially it was last year it was 5,000 rupees.
Sir, I
It has
search on
increased up to
Google,
7.
so sir, it shows approximately 3,200.
Must
Now
be
recently price,
it's available or not, that you have to see.
so it is sold out, sir. But
Sold out, yes, yeah, that's the main thing. Yeah, that must be old price. So whenever the stock will be available, and if you see the price again, then it will be increased.
okay. Means, there is so much difference in price, so I'm in confusion that whether it is the same board or it is the another board.
Yes. Yeah, there is always confusion. But see, whenever you are getting the specification, just you read the specification. In the specification, there must be Wi-Fi as well as Bluetooth both. If the
And
specification is there,
And that the ARM Cortex processor is important.
ARM Cortex processor is important. Yes, yes. That these are the
Okay.
questions
It is
just.
that the ARM Cortex is the most important for the
Yes, yes, you are right.
for machine learning applications.
Yes, yes, you are right.
Yeah. Yes, sir.
Just I will take a break of 2 minutes because two professors came to meet me. So just I will continue after that. Meanwhile, you can in between you can. So let's discuss it again. So there are actually for a internet applications, if you require to transmit the data or if you want to control the data locally with a distance of about 100 meters, then Zigbee is also very good. Zigbee modules are available. And this is what I was talking about is the Node MCU board. These two are both are Node MCU board in a different so this one is also the Node MCU board and this is also Node MCU board. And this is a LoRaWAN module. So this is very useful if you want to communicate the data within a long distance of about 1 kilometer, then LoRa module is very, very useful. And this module is the Jetson Nano board. Higher configuration than the Raspberry Pi, more computation power compared to the Raspberry Pi, and more number of USB ports are available. Heatsink is also given on the CPU so that you can run it 24/7. Raspberry Pi board is having a limitation that if you run it 24/7, sometimes it becomes very hot actually because a lot of heat is generating and there is no heat sink. Here they have provided the heat sink, so heat can be dissipated through the air with help of this heat sink. And this is actually a Wi-Fi module. This is a Wi-Fi module which is actually very, very useful if you want to give a internet connectivity to a board like Arduino, Uno, or 8 mega, which the board which doesn't have any Wi-Fi capacity, and if you want to give the Wi-Fi connectivity to that board, then it's a very small board, low cost board costing only 99 rupees or 100 rupees. You can connect this board with a Arduino board, and you can make it compatible with the IoT devices. Then this is a Bluetooth module. So if you want to communicate the data locally, within a room, then you can use this Bluetooth module, where there are pins like RxD, receive data, TXD, transmit data, ground, VCC. These 4 pins are important. Then while configuring this particular Bluetooth module, enable pins sometimes we, but otherwise for normal communication, only these 4 pins we need to connect with the microcontroller board or any IoT devices. Most of the IoT devices nowadays are having an inbuilt module available. But if there is no inbuilt Bluetooth module is available, and if you want to give the Bluetooth connectivity, then this Bluetooth module you can use. So for give the Wi-Fi connectivity, you can use this module. This is known as the ESP8266 module. And to give the Bluetooth connectivity, you can use module like this HC06 module. But the latest Raspberry Pi and latest Node MCU board is having already the Bluetooth and Wi-Fi connectivity both together available. So we don't require such modules in those boards. But suppose if you want to use Arduino Uno board and it doesn't have a Wi-Fi capacity, it doesn't have a Bluetooth capacity, and then you can connect these 2 devices with the Arduino Uno board. Then sensors and actuators are very, very useful components for IoT applications. So the transducer is a device that converts the one form of energy into another form of energy. And special types of transducers which are used to sense the physical environmental quantity are known as sensors. Special types of transducers which are responsible for moving and controlling a mechanism or a system are known as actuators. So ultimately, the sensors will be connected to the microcontroller pin, where pin we have to configure as an input pin, because the sensor will give data to the controller, while microcontroller will give output to the actuators. So wherever we connect the actuators, those pin we have to configure as an output pin, because actuators is the devices to which we will be giving the signals, and the sensors are the devices from where we will be getting the signals. So actuators requires a control signals and source of energy. So some kind of a solenoid, a relay. Solenoid can be electromechanical solenoid or electronic solenoid also. Electromechanical relays is also available. Electronic relay is also available, where there is no moving part is there. Then controlling device is the brain of system, which takes the data from sensors, activate or deactivate the transducer as and when required. So this controlling device, that means our ARM microcontroller or a AVR microcontroller or a PIC microcontroller, which is ultimately our CPU of our board, which takes the data from the sensors, process it, give a signal to the actuators, or sometimes transmit this data through Wi-Fi to the cloud. In IoT applications, basically, it will be connected with the network, so that it will be able to control the devices remotely anywhere from the world. So real world physical environment will be, the sensor will sense it. Then actuators, basically digital representation of electrical signals. So actuators and sensor, these are very, very useful. So actuators are used to manipulate the physical environment. Sensors will measure the physical environment. And then if you want to change the environment, then there is a job of actuators. So actuators will do that task. Like for example, you sense a temperature with help of a temperature sensor. And temperature is high. What you will do? Your actuators will turn on the AC. So when it will turn on the AC, your temperature will become down. When it is less than certain limit, again actuator will turn off the compressor available inside the AC. So automatically the power consumption will reduce, and again the temperature will be maintained. So this cycle, this closed loop system is always there between the sensors and actuators. The actuators will take electrical input and turns it into the physical action. It turns on the compressor, turns off the compressor, turns on the valve, or sometimes turns off the valve. So depending on the required flow of the liquid inside the pipe. So ultimately, all the actuators are used to manipulate the physical environment by controlling the various parameters like a flow or a temperature. It will basically control the different parameters. So layer says we talked that there are many sensors available like GPS, electrochemical, photoelectric, RFID, gyroscope, electromechanical, etc. Basically, it takes the data from physical world. Then smart devices are integrated with the sensors. Information like temperature, humidity, pressure, flow, air quality, motion detect, acceleration, vibration, etc. is captured and transferred to the digital world, that is IoT systems, by smart sensors. For asset tracking like GPS, RFID is used. The wide variety of sensors are available and sensors are selected based on applications. We will discuss here today a few sensors, but again there are wide varieties of sensors are available. If you look at the classification of sensors, there are different sensors can be classified based on detection principles. There may be electric sensor, magnetic sensor, electromagnetic sensor, acoustic, chemical sensor, optical sensors, heat sensor, temperature sensor, mechanical sensor, radiation sensor, and biological sensors. These are based on the detection principles. So categories are accordingly bifurcated into different way. Then sometimes what type of physical law involved for its operations? Photoelectric, thermoelectric. So these are all different physical laws: photoconductive, photomagnetic, thermomagnetic, thermooptic, electrochemical, magnetoresistive, photoelastic. So all these sensors are classified in that way based on the physical law. Then based on space also there are sensors like how much accuracy they are having, how much sensitivity they are having, stability, response time, stresses, frequency response, then what type of input it allows, resolution, linearity, hardness, cost, size, weight, conduction material, temperature, etc. So based on the specification also the sensor categories are there. The temperature sensor which is useful at home as well as in the satellite, both will be completely different, although the purpose is same, to measure the temperature, but the where they are using, whether they are using in industrial environment, whether they are used at a traffic junction, or whether they are there on the satellite, depending on that all will change, and depending on that you have to select the sensor. Sensors can be also classified based on application, like whether it is useful for agriculture, automotive, civil engineering. In civil engineering and construction works nowadays, many sensors are being used. Domestic appliances, commerce, finance, environment, metrology, security, energy, information and telecommunication, health and medicine, marine, military and space, recreation and toy, scientific measurement, manufacturing and transportation, and many more. So various applications of sensors are there, and that's why IoT is very wide. IoT is everywhere, and nowadays it is becoming buzzword nowadays because of that only, because it is useful in many engineering discipline, engineering and science applications. Some sensors may not be able to convert directly into physical quantity into measurable low power electronic signal. So what we require multiple conversion between before reaching into the measurable signal. So mostly such sensors are analog sensors. So analog sensors, sometimes you require instrumentation amplifier after that to amplify the signal. The capability of instrumentation amplifier is that it will amplify, along with it will also reduce the noise, because the instrumentation amplifier is having a two input. So noise is present in both the inputs. It will be cancelled automatically. So only signal will be measured, noise will be removed. Well, digital sensors provide digital output and all calibrations and conversions are done internally. So many times, it's better to purchase the digital sensors, because digital sensors are already having a noise cancellation inside. Most of the calibration is done internally. And the advantage is that only digital output is available, so very easy to interface with our IoT device. So people are preferring nowadays digital sensors instead of analog sensors. And advantage of digital sensor is that you can connect directly with the Raspberry Pi kind of a board where ADC is not available. You don't require any separate ADC from outside, because digital sensors provide digital data directly. So sometimes it is very, very useful. But mostly all our real world signals are analog in nature. So of course, digital sensors are also using ADC internally, and converts that signal analog data into digital data, and then it provides digital data to us. So our job becomes very simple. Then another classification is active sensors and passive sensors. The active sensor, as the name says, that a sensor that requires external power to operate it, like carbon microphone, thermistors, strain gauges, capacitive and inductive sensors, etc. They cannot produce signal of their own. They require some extra DC power or AC power to operate. Mostly it requires a DC power. The active sensor is also called as a parametric sensor. Then there are many passive sensors which doesn't require any external power. It generates its own electric signal and doesn't require power source, like thermocouples, magnetic microphones, piezoelectric sensors, photodiode. This doesn't require any extra power, but they can generate the electric signal of their own. The passive sensors are also known as self-generating sensors. Then there are contact sensors and non-contact sensors. The contact sensors require a physical contact with the stimulus, like they require to connect with that. So strain gauge, because on the strain gauge you have to put the weight. Temperature sensors, so it should be directly in that ambient temperature. There are many non-contact sensors are also there. They do not require any physical contact, like most optical and magnetic sensors, infrared thermometers. So all these non-contact sensors we were using during our Corona time, because at Corona time, touching sensor was a dangerous job. So no one would like to touch. So people were using the non-touching sensors. So non-contact sensors were very, very useful during the COVID time. Then there are absolute sensor and relative. So absolute sensors actually gives the reading directly absolutely, and the relative scale sensors will give the data relative to some ambient data, like ambient atmospheric pressure, ambient temperature, or that kind of thing. So if you look at the examples, then one example is of temperature sensor is LM35. This is again analog sensor. It provides the temperature data, analog data at the output. 3 pin is available. One pin is supply pin, another pin is the output pin, which is shown here. So this pin number 2 is output pin. Pin number 4 is supply pin, where you can connect the 5 volt. The range is given here 4 to 20 volt, but if your board is operating with 5 volt, then normally we connect the 5 volt here. Then third pin is the ground pin. So this pin is normally grounded. So only a 3 pin is available in this sensor, and the operating voltage is 4 to 20 volts. Usually we give the 5 volt here. Operating range is, this is useful if you want to measure temperature in the range of minus 55 degrees centigrade to plus 125 degrees centigrade. So industrial furnace where the temperature is very high, at that place this sensor will not be useful. So in that case you have to use thermocouple, because thermocouple you can use at very high temperature. This sensor itself will damage if the temperature is more than this. The accuracy of this sensor is 0.25 degrees centigrade, 1/4 degree centigrade. I think there is one question in the chat. I got it. See that. do we use this LM35 mobile charger or power bank? Mobile charger and power bank, if you want to measure the temperature, then it is required. Otherwise, normally it is not required. But yes, this is very useful nowadays. If you have seen the Ola scooter, electric scooter, because of temperature rise, actually sometimes there is explosion in the battery. In that application, you can use this. It will currently it will monitor the battery temperature and will stop charging automatically if the temperature is more than a certain limit given by the battery. So normally during the charging, battery temperature increases more than 90 degrees centigrade, then automatically charging should be stopped. So for that type of applications, sensor. But I think mobile charger doesn't increase that much temperature, so that's why it's not necessary there. So V out is analog voltage on pin number 2 of LM35. Need to convert this to digital with help of a ADC. And ADC reading needs to convert and calibrate into the temperature degree. So again, whatever the output we are getting here is in terms of millivolts. But for a user, millivolt is not important. For a user, degree centigrade should be there. So in output, to display the result, you have to convert that reading into the degree centigrade. So for that, you have to put the formula in a program. So in a program, you have to use the formula which will convert the millivolt into the degree centigrade. So this is already asked. Then one more temperature sensor is a DS18S20. So previous sensor was analog sensor. This is a digital sensor. The temperature output, 9-bit temperature output is given, but you will surprise that 9-bit is there. So there should be 9 pin for this IC, but only 1 pin is given as an output, data output. So what is that the data is sent serially. All 9-bit is sent serially through this 1 pin only. Right? So you will get the serial data from here, and then you have to interface with the one of the serial pin available with the IoT device. So it is sometimes known as a one-wire interface because only one wire is giving you a data. Operating voltage is again 3 volt to 5.5 volt. So ARM processor is operated at 3.3 volts. So this is very much suitable for ARM because it can operate at 3.3 volt easily. Previous sensor LM35 actually require some more things before you use it with the ARM, because for that you have to apply 5 volt because the range is 4 volt to more than 4 volt you require in that case. You cannot directly connect the supply which is available on ARM board. So you require to give the different supply to the LM35 if you want to use it with the ARM board. Operating voltage is again same as the previous one, minus 55 degree to 1 plus 125 degree centigrade. Accuracy is 0.5 degree centigrade. And unique 64-bit serial code is generated so that multiple devices can be connected using single wire interface. So very beauty of this sensor is that at a time you will be able to connect many sensors on a same pin, because all sensors before transmitting the sensor data, they transmit their own unique code, their own address. So they send the address and then data. So total actually 64-bit message is being sent to the IoT devices. Then IoT devices will receive the 64-bit. It will analyze from which sensor the data is coming, and accordingly it will display on the user display. Right. So you can connect all these sensors together on a same pin. That's the beauty of this sensor. Then one more sensor is a body temperature sensor, that is also known as a MAX 30205 body temperature sensor. This is also a digital sensor, but here the main difference is the range of temperature. The range of temperature is 0 to 50 degrees centigrade. because body temperature we know it will not increase more than 50 degrees centigrade, right? So it doesn't also require minus measurement. So minus 55 to plus 125 degrees centigrade is not important here. But here the what is important is accuracy. You require more accuracy in the range of 37 degrees centigrade to 39 degrees centigrade. So here accuracy is more. It is having accuracy of 0.1 degrees centigrade. So that's why it is very, very useful for biomedical applications where you require a more accuracy. Right? So that's why instead of LM35, students are using for a biomedical application, students will choose this particular sensor because this sensor will gives them more accuracy. Then it has a 16-bit temperature resolution. Right? So resolution is also very good. I think one more question is there on the chat. I will just look at this. Arduino Nano BLE Sense module is similar to Arduino Nano board header. Yes, yes, both is same. Only with header means the IO pins are all soldered with the board. If you purchase without header, then you have to solder it yourself. If you purchase with header, then it will come along with the soldering. So you don't require a external what is not
Okay,
that
sir.
you don't require soldering, right?
Okay, sir. Its cost is the 2285.
2285. Oh, then it's okay. Then you can. It's very easy.
And it is available. And it is available in market.
Very good, very good. Then you can purchase it and you can solder yourself your that header. Actually, it's not a very big job, right?
It is suitable for the machine learning application, sir.
Yes, yes, it is suitable. Yes, it is suitable.
Okay, sir. Okay. Thank you, sir.
Then one more is the proximity sensor. There are many types of proximity sensor. So ultimately here you can see in this proximity sensor, there are, IR, LED and IR sensor is there. So LED is transmitting and sensor is receiving the light. So if there is some object, then light will reflect and received back to the receiver. If there is no object, you will not receive any light. And you can also detect the proximity, how much object is close, whether it is a close 10 centimeter or 20 centimeter. It can measure up to the 80 centimeters. So not only it will sense whether there is an object in near proximity, it will also measure the distance. So what it does is it emits the pulse of infrared light and then detects the angle at which the light is reflected. The following object is the lower voltage, the sensor receives no reflection. The output voltage of the sensor will be 0 volt. No reflection means no object is nearby, so you will get sensor will get 0 volt. If the object is 10 centimeter or closer, the output voltage will be equal to the 5 volts. So maximum voltage you will get, and from that you will be able to see that okay, yes, object is near to the sensor. And if object is anywhere between the 10 centimeter to 80 centimeter, the voltage will be less somewhat. So it gives you a different voltage. Yes, I got I got the message in the screen that the cost variation is because sometimes it depends on company also. Like if you purchase the multimeter job is to measure the voltage and current and resistances. But you will find the multimeters in the range of even for 100 rupees also you will get the multimeter, and 10,000 also you will get the multimeter. So of course the reliability is an issue. But sometimes you want to use it for lab purpose, then if you do not think about the reliability, sometimes it will work because for industrial applications, people worry about the reliability and all that because they want to run it 24/7. If you are purchasing it for lab purpose, you don't want to run it for 24/7, then you can purchase, with a lower cost also, no problem. Yes, original cost, as I told you, 8976, around 8,000, 1,000, it will come. But you will also get it with a lower cost from somewhere else. Then this, which I have shown to you, that ultrasonic distance measurement sensor, HCSR04. It works on the principle of sonar or a radar. Range is 2 centimeter to 400 centimeter distance it can measure. Pulse of 10 microsecond or more is given to the trigger pin. So there are 4 pins. One is known as a trigger pin, another one is a echo pin, one is VCC, another one is ground. So all 4 pins are available here. So it generates the pulses of 40 kilohertz, and then it transmits, and echo pin is switched to the logic high. So whenever it transmit the pulse, the echo pin is switched to the logic high. If there is any object nearby, then the pulses will echo back, and echo pin will switch to the logic low level. So now you have to measure the duration of pulse. So you transmit the pulse, you receive the pulse. In between the time, you will get as a pulse width, and based on this that width, you will be able to measure the distance. So distance is here, duration multiplied by 0.0133 divided by 2, because you know that ultrasonic the velocity is 340 meter per second. And when you convert that into inch, you have to divide it by 2.54. So the reading will be in centimeters, because you know that 2.54 centimeter is 1 inch. And here you can see that divided by 2, because it is a to and fro distance. The signal is traveling to the object and then coming back, reflected back from the object. So it is a to and fro distance. So we are dividing it by 2. So whatever the distance you are getting with help of this formula will be in inch, right? So depending on the how you require a distance, you require whether it is in a centimeter or a meter or an inch. Depending on that, you have to modify this formula. And this is actually overall view of the different sensors: color sensor, gaze sensors, LDR, that is a light sensor, LM35, alcohol sensor, particularly useful in automobile application. On a steering, you can put this sensor and the device. If the your driver is drunk, then the vehicle will not on itself. That type of application. Even with help of IoT device, you can also inform on the vehicle that driver is not in a correct position. You should not allow him to drive the vehicle. Smoke sensors, thermistors, ultrasonic sensors, soil moisture sensor, gyroscope, humidity sensor, phototransistor, touch sensors. All these are the different heartbeat sensors. All different types of sensors are available in a market. And in a laboratory, if you use these are very low cost sensors. You can easily use in the laboratory. Some of the sensors are again shown here, with PIR motion sensor, door sensor. Automatically, it will say that whether door is open or closed. And this is a temperature sensor which we were talking about. This is a smoke sensor, capacitive touch sensor. This is a DHT sensor. This is basically white one is known as a DHT11. Sorry, this white one is a DHT22, and this blue one is a DHT11 sensor. Both is same almost. There are 4 pins available: VCC, data. Third pin is not useful, and the fourth one is ground. So out of these 4 pins, only 3 pins are useful for the interfacing. Then these are the light sensors, flex sensors, accelerometer, which will measure the XYZ position. Then camera. Camera, of course, you will not be able to interface with Node MCU board, but you will be able to interface with Jetson Nano board or Raspberry Pi board. Then these are the different IoT protocols. At different layer, actually, different protocols are being used. At link layer, there are variety of protocol, because we know the heterogeneous network is there. So heterogeneous is there, so then there will be a Ethernet, Wi-Fi, WiMAX, wireless personal area network will be also used, like a Bluetooth, Zigbee, and all that. Then 2G, 3G, LTE, cellular, all this protocol will be useful, because our network itself is heterogeneous. So naturally, all the protocols which are useful in heterogeneous network will be also available here for the IoT application. In a network layer, we use IPv version 4, version 6, as well as LoRaWAN. So it is a basically wide area, but low power network, right? TCP UDP network transport layer protocols are useful, and in application MQTT is very popular. Apart from the MQTT, people are using HTTP, COAP, constraint application protocol, WebSockets, DDS, AMQP protocol. These are the different protocols people are using for IoT applications. These are the full forms given here. MQTT is basically message queue telemetry transport. Publish subscribe type of a protocol. Constraint application protocol is basically a variation of web-based protocol, because IoT applications where you require to minimize the power consumption. So for that purpose, that protocol is modified. AMQP, DDS, and STOMP protocols are useful in IoT. Apart from that, VSCP is also there. A very simple control protocol is there. And basically, the IoT drivers are basically high-speed internet widely available at a present. So that's why IoT is becoming boom, because internet is easily available. Then availability of Wi-Fi enabled devices. So easily Wi-Fi is available, so we can go for IoT. Growing smartphone adoption, people are using smartphone. Increasing in laziness, we are day by day we are becoming lazy. We want to operate the devices without, we don't want to stand up and close the switch. We don't want to go to the field, and we want to see everything from the control panel. So sometimes laziness is also giving, it becomes IoT driver. Of course, it is a non-technical. Availability of low-cost Wi-Fi chip, which can be attached with the sensor to make it smart. So only Wi-Fi chip, as I told you, ESP8266, available only with 100 rupees, which you can connect with any microcontroller to make it IoT compatible. Low cost and small size embedded chips are available, like Atmega 328, Atmega 32, Peak, as well as this Node MCU device, Arduino Nano device. As you have seen that, Arduino BLE device is available only at 2,500 to 8,000, with all capabilities like Bluetooth, wireless. You can run machine learning algorithm in that, ARM processor. Everything is available with that cost. So Node MCU part, actually, I have another session today. Madam, should I continue just now, or should we discuss this part initially on Saturday, and then we will discuss Python and MicroPython?
Yes, sir. That is also fine. No
Fine.
problem, sir.
Okay.
Yes.
So I think here there is a topic change, so I will stop here, right?
Yes,
And
sir.
from this point onwards, we will discuss on Saturday
Yes.
in Node MCU. So we will discuss first of all Python, then about MicroPython, and then I will come back to this Node MCU.
Okay.
And then
Yes.
I will do some demonstration of MicroPython as well as Arduino both on Saturday.
Yes. Yes, sir.
Okay.
That will be fine. Yes.
All right.
So thank you so much, sir, for your again informative session. And once again, I thanks to you from on behalf of HRSC Nagpur, sir, for accepting our invitation on 11th hour. And thank you so much, sir. Thank you.
Any questions are there? I am here to answer.
या फ्रेंड्स कुछ क्वेश्चन है तो आप पूछ सकते हैं सर चैट बॉक्स में मैक्सिमम क्वेश्चंस थे जो आपने आंसर
हाँ,
उनके दे चुके हैं
ठीक
आप।
है, ठीक है, ठीक है। तो हम लोग क्या करेंगे, सैटरडे को थोड़ा डेमोन्स्ट्रेशन भी ले लेंगे, सेंसर डेटा को कैसे क्लाउड पे अपलोड करना है, और डिवाइस को कैसे मोबाइल एप्लीकेशन से उसको कंट्रोल करना है।
जी
वो
सर।
सब करके वो माइक्रो पाइथन से भी करेंगे और आर्डुइनो से भी करेंगे,
यस
और पाइथन भी उसके साथ डिस्कस कर लेंगे, है ना।
सर देयर इज वन क्वेश्चन फ्रॉम प्रवीण सर, काइंडली
हाँ।
सजेस्ट एनी बुक फॉर स्टडिंग ऑल द प्रोटोकॉल्स टुगेदर।
Rahul Dubey is the book, actually, Internet of Things by Rahul Dubey, where
Yeah.
protocols are given.
प्रवीण सर काइंडली नोट इट डाउन। यस यस
Okay, thank you very much to all
थैंक
for
यू सो
attending
मच
the
सर।
session.
Thank you
very good
once again,
audience,
sir.
I think. Yeah. Okay.
Yes, sir. Very interactive batch.
Yes, yes. Good.
Yes.
Yeah.
Thank you so much, sir. Once again. Have a nice day, sir.
Okay, good. Okay. Goodbye.
Good day, sir. Thank you, all of you. Just a minute. Don't leave the meeting, participants. There are some instructions. Just let me stop the recording.